Hi, I'm Jonathan, and welcome to Defining Advanced Control Policies for SD-WAN. So in this topic, we're going to define how to define control policies, such as arbitrary VPN topologies, from simple hub and spoke to complex hierarchical policies. The lesson is going to explain how to perform traffic engineering, such as preferring one path over another, and how to do service insertion and chaining. If you're not familiar with the phrase service insertion, basically means I drop a firewall into the path or some other device, an IPS, a web proxy, etc. And service chaining is if I do multiple devices, so a firewall and an IPS and a web proxy, and I can keep doing that. So that's what service chaining means, and service insertion. Okay. Later on, we're going to be covering traffic engineering and QoS and the zone-based firewall as well. Okay. So once we're done with this topic, you should be able to describe control policy basics, how to define arbitrary VPN topologies, and by arbitrary I mean this VPN has to talk to that VPN through this VPN, etc. And we're also going to talk about describing those advanced control policies and implementing any hierarchical topology, which means stuff needs to route from this site to that site to that site. And basically, and also talking about preferred path, so if I want to prefer one link over another. And we're going to talk about how to define advanced policies for service insertion, okay? And how to implement shared services. Well, these may not make sense right now, but as we progress, we'll get into more details. So, control policies, as we discussed in the last section, are configured in vManage, and then are sent to the vSmart controllers. They're never sent to the vEdges themselves. The vSmart controllers use the policy to filter and modify that OMP routing updates to the vEdges. vSmart sorts are automatically synchronized so that each vSmart has the same view of the network. So if I say this site should not get the routes to this other site because those are restricted, the vSmart just won't allow that site to see those routes in the first place. Centralized policies influence the entire SD-WAN fabric. Therefore, central control policies are very powerful and must be well understood and tested before deployment. And down here we have a list of the devices that we can actually, the types of things we can actually do with these. So, one of the things we can do, because we run OMP over the overlay network and runs between all vEdges and vSmarts, all control information is going to be exchanged on the network over OMP. All right? So the first step, all vEdges are going to announce to the vSmarts what they can see locally, the service-side networks. All right? So site 3 here can see this network, and it's going to advertise that network into the environment. Site 2, that network into the environment, etc. Okay? An inbound policy could change this incoming flow of information. Therefore, an inbound policy could change what the vSmarts see in their routing database. So vSmart is going to get this advertisement of 2.2.2 for site 2 and advertise it to both site 3 and site 1. This is the normal behavior. If you have no policies in place, this is how we operate. We advertise your locally advertised service networks to everyone else. After the vSmart controllers receive all those OMP updates from the vEdges, the vSmart controllers store this information in their routing databases. If an incoming policy modifies those OMP updates, the vSmarts store only the modified information. This way, the routing databases hold a central view of the entire SD-WAN fabric. Okay? And here's the, so vSmart is aware of everything. Okay? Now, vSmart has gotten all these updates, now it has to distribute them. By default, of course, it's going to distribute the entire update to everyone, except the one you received. So site 2 isn't going to get 2.2.2.2 back. There's no reason for it. So it does filter out your own advertised update. We do have some split horizon here. Okay. vSmart also pushes its routing database through OMP updates to the vEdge with the out direction, i.e. to get to 2.2.2.2, use the TLOC to go to site 2, right? And this is an example of what they got. And you can see that the locals are filtered out on each of these. By this method, each vEdge is going to learn about all the other vEdges, how to reach them, the transport locators, the TLOCs, and which key to use to encrypt the data toward the vEdge, and so on. What's included here, by the way, when I say that, is all the security information for the IPsec. sorry, my handwriting's a little off. The IPsec information, the certificates, and everything else, and how we can secure that connection. Okay? The vSmart controller in the SD-WAN has a similar role as that of a route reflector, right? Remember, the vSmart gets all the routes and then reflects those routes back. If you're not familiar with BGP route reflectors, don't worry about it. But if you do, you understand how this works pretty obviously. If you don't, here is a one-sentence, 100,000 kilometer view. Basically, instead of it creating a full mesh of connections, one node is selected to reflect all the routes to the other. In this case, vSmart. An outbound policy might change the information distributed to the v-edges, and therefore the view of the network on the v-edges. For example, let's set network 2.2.2 to route via TLOC 3 on site for just site 1. So we're basically changing this from a 2 to a 3, right? And a policy can do that. So even though we still have the route for 2.2.2, right? Instead of routing it this way, we're going to route it this way. Okay? And we can use an outbound policy to enforce another topology. In the example shown, a centralized policy is applied to vSmart as follows. The policy is applied only to site 1, so announcements to other sites remain unchanged, right? The policy statement matches all announcements of site 2 and changes the TLOC to 3. As in effect, packets from site 1 to site 2 are actually sent to site 3 instead of to site 2. As an example, you can use this mechanism to do service insertion of a firewall or some other service. Okay? So let's say we have a firewall here. It's on fire. And we want to route all traffic through the firewall and then back down. The way we would do that is with one of these we do a service insertion and an outbound policy change. Okay? So how do we do this? So before we talked about how to define a simple hub and spoke topology by selecting hub and spoke up here, and then defining the hub sites, selecting the hub sites from our site list, and selecting the spoke sites, the branches, to our spokes. In this example, we're going to show a more complex control policy for creating a custom topology. So when we're doing a custom policy, we're going to choose this custom control route, this NTLOC right here, okay? And then choose two types of control policies. A route policy, which will affect the way the vRoutes are distributed. That's this guy right here. vRoutes cover the service side of the network, the local LANs behind a vEdge. And a TLOC policy affects the way that TLOC information is distributed. In the top right corner of vManage, under Custom Options, you can modify this policy. Okay. So if you need to go back or change a place in the steps, you can do it here. So if you want to go back and add a list or a topology or a traffic policy, you can move around, navigate from there. So most control policies are going to be centralized policies which affect those transport networks. Localized control policies are going to affect the service side routing at a single site on a specific vEdge router. Localized control policies are like traditional routing policies in a network. We're going to recommend you use the vManage GUI templates to define policies and not CLI templates. CLI templates are more generic, but also far more error prone. Due to the large number of routing options and parameters for BGP and OSPF, some routing options are not available through the GUI method yet. For such cases, your option is only the CLI. Okay, and as we move through this. So, in the example on this slide, VPN 1 should have a hub and spoke topology. So here's the VPN 1s. All right, so we're going to use a hub and spoke topology for VPN 1. Let me note that up here. Actually, you know what? That's right there. Okay. And VPN 2 should have full mesh because VPN 2 is being used for voice. So because voice needs to be full mesh. Because a phone over here needs to talk to a phone over here. And there's no reason to route that voice audio stream through the data center. All right, so remember this is MPLS, so the underlying topology is already any-to-any. So the control policy is going to be pushed to all involved sites and defines the following for each of those VPNs. VPN 1, spokes are going to receive only the data center prefixes, not the prefixes to the other spokes, just the hub. So VPN 1 is going to receive just the VPN 1 prefixes from the data center. Okay? VPN 2, every spoke receives information